Here's a scene that allows you to demonstrate how to tune anti-aliasing in XSI. I've created the scene, which is simply a cube that's been extruded and have been replicated every 1 degree on a given axis to be able to create this very challenging image to render for XSI. The current rendering settings are quite very poor quality, let's say. The minimum and maximum values, we're starting about having really using undersampling and going to super sampling, which is pretty much 4 samples per pixel. But the threshold has been set so high, which basically mean very poor, that we get this image that has been rendered. And this is pretty much the same thing as if I was rendering directly a -1,1 because the threshold is so high. So we'll start to lower the actual threshold and start to pick up the details. So you see these miroir-in patterns are simply caused by lack of sample, and this is aliasing. So by lowering the actual threshold, we simply allow mental ray and XSI to break up the pixel into finer, up to 4 sub-pixel in this case. So now we're starting to resolve some of the artifacts. As you can see, Jitter here really help the actual final render. Let's say we disable it. So you see that our very visible patterns that appears here. And obviously to be able to resolve that, we need to enable Jitter, which take the actual sampling position and jitter it slightly such that it's not being sampled on a evenly spaced into the actual image plane. So as we lower the actual result here, we actually asking mental rate to do a better job. Here we could see that going from, let's say, 0.3 to 0.014 doesn't really add any value or quality to the image. This is pretty much limited by these settings, which are very poor. So let me put it back to a preview quality, which is pretty much 0.2, and start to increase these two values by 1. So now, as you can see, we're starting to actually resolve some of these artifacts. So some of these lines will render okay, but some of those here will still have aliasing artifacts. So there's ways to actually solve this particular problem. One of the first ways to options you have to resolve these artifacts is by lowering the threshold again. So some of these artifacts will eventually disappear. So let's make it very small. As you can see, we've pretty much reached the maximum quality for a max sample of 2 here. Even though it's really small, we see that the image is not really improving. So now this is the time to increase the anti-aliasing settings by 1. So let's put back this thing to preview quality and increase only this one by 1. We'll leave it to 0 because we want the system to really do the minimal work. So if you make these two values really close together, that doesn't leave that much room for the algorithm to be adaptive. So you really want to keep these two parameters as far as possible, which is basically a maximum distance is 3. So if you increase this one by 1, this parameter will basically follow. So I strongly suggest to keep these two with the delta 3. So now you see that the image is actually much better. The artifacts in the middle are kind of gone. So I can actually start to lower the actual threshold here, and I'll be starting to resolve some of the artifacts here. So let's put it very small here. So you see that the rendering is a little bit slower because he has to break up the pixel more often. So now we have pretty much reached the maximum. We could actually increase it up to 4, but that will involves a lot of memory and a lot of time. So I wouldn't suggest you to increase this one up to 4. Although if you do make it in this case, you'll see that the actual render is much slower. And the actual render quality, I don't think it's going to resolve any of the artifacts that we see here. So as I said, the artifacts are still visible even though you have increased the anti-aliasing settings. So let's put this one back to what it was, the 0 and 3 in this case. And now let's use really filtering. So filtering is really the one of the ways to actually continue to do these filtering to resolve these aliasing problems. So let's first set it to triangle. So you see that the actual line is becoming thinner because the actual filtering is a triangle shape. So the pixel or the samples in the middle is more important than the one near the edges of the pixel. That's why we have this impression that the line becomes thinner. So now we have pretty much resolved the artifacts, and this is gone right now. We could have put it to Gauss, but in this case it is not required. It will tend to even blur out even more the image and make it even more smooth. So that is at this stage, it's really up to you to decide if the quality you want to achieve requires Gauss or triangle. This is pretty much how you tune anti-aliasing in XSI, and how to use jitter, threshold, filtering, and min and max value.